Before discussing acid-based titration, let us first look at a real environmental pollution case in Malaysia. One of the most well-known pollution incidents is the Sungai Kim Kim contamination case, which occurred in Pasir Gudang, Johor in 2019. The incident was caused by the illegal dumping of chemical waste into the river. As a result, toxic fumes were released into surrounding area. More than 1,000 residents and students experienced symptoms such as breathing difficulties, nausea, and eye irritation. Several schools in the area were temporarily closed. Following the incident, environmental authorities collected water samples and carried out laboratory analyses to identify the pollutants and determine the extent of contamination. So let's get started.
Welcome to the Neutral Zone, the podcast where we dive into the science-solving real-world environment crime. I'm Stephen Tantinswa.
And I'm STESHA. Today, we are fulfilling our analytical chemistry VOD test project. We are focusing on environmental forensics, evaluating how we test water quality using acid-based titration.
To ground this in a local context, we are looking at the incident like tragic in 2019 Kim Kim River toxic pollution in Johor, when illegal chemical dumping happens. Investigators need immediate evidence.
Exactly. Today, we have 4 experts rotating into the studio to help us evaluate how classical wet chemistry tracks down the culprit. Steven, take it away with our first guest.
Alright, thanks Mr. Titration. I'm here with our analytical chemist, Mr. To. How do we measure acidic pollution?
Okay, we use a principle called acid and base titration. It relies on a neutralization reaction. If polluted river water is highly acidic, we take that as sample and slowly add standard solution, which is a base like sodium hydroxide with a perfectly known concentration.
Okay. How do you know when to stop adding the base?
We add a chemical indicator to the river water. As we drip the base in, we watch for a color change. The exact moment the color changes permanently is called the endpoint. This means the acid is completely neutralized. By measuring the volume of the base we use, we can calculate the exact concentration of the pollution.
Alright, thank you very much.
That sounds straightforward, but I'm joined by environmental forensics expert, JESSIE LIAU. JESSIE, let's critically evaluate this. Is manual titration actually the best method for legal evidence?
In my opinion, I think it's a trade-off, STESHA, because the biggest strength of classical manual titration is portability and speed. In a mobile field lab near a river, which is here as an example, it requires no electricity and gives officers immediately quantitative data to assess the danger level.
But it has limitations, right?
Yes, it relies on the human eye for color changes, which cause subjective error. More importantly, it only tell us the total acidity. It doesn't tell us which specific acid was dumped.
So what is the alternative?
We compare it with modern instruments like ion chromatography. Ion chromatography separates and identifies the specific chemical fingerprint of the pollutants. So, our verdict: the titration is the best rapid response screening method for the field, but we must justify using instrumental techniques in the lab for the final court evidence.
Thank you, JESSIE.
Alright, now I'm with our lab technician, Mr. TENG. River is full of mud, right? You can't just titrate that, right?
Yeah, exactly, Stephen. If the water is murky, you can't see the indicator change color. Sample preparation is mandatory. So firstly, we use vacuum filtration with a 0.45 micrometer membrane to remove suspended solids and debris.
What happens after the water is filtered?
So we have to maintain the strict precision for forensic validity. We use a volumetric pipette to extract a highly accurate liquid usually 50 milliliter, and we transfer it to our titration flask. Then it's ready for analysis.
Thank you very much.
Thank you.
Speaking of analysis, let's run the numbers. And with our data analysis, Hongze, show us the map.
Okay, gladly. Let's say Jeon prepared a 50 ml sample of pure water, and Mission titrated it using a standard 0.05 molar sodium hydroxide solution. And let's say it takes 14.2 ml of the base to trigger the endpoint.
How do we find the pollution concentration?
We use the formula M1V1 equal to M2V2. Calculate the moles of the base. 0.05 molarity multiplied by 0.0142 liter equal to 0.00071 moles. Because it's a 1-to-1 neutralization, we know there's only 0.00071 moles of the acid in the water.
And the final step?
The final step is divide those moles by our 0.05 liter sample volume. That gives us 0.0142 molar. For a river, that concentration is incredibly toxic and provide illegal dumping.
Thank you.
In conclusion, acid-based titration is an effective analytical technique for investigating water pollution because it provides reliable quantitative data and supports environmental forensic investigations. However, identifying pollution is only the first step. Preventing pollution is equally important. To avoid incidents such as the Sungai Kim Kim pollution case, industry should ensure that all chemical waste is properly treated before being discharged into the river. Regular water quality monitoring should also be carried out by environmental authorities to detect contamination at an early stage. In addition, stricter enforcement of environmental regulation and heavier penalties for illegal waste disposal can help reduce pollution incidents. Public awareness and community reporting are also important, as local residents are often the first to notice signs of environmental contamination. Through proper waste management, continuous monitoring, and cooperation between industry, authorities, and the public, water pollution can be prevented and our environment can be better protected.
So, to wrap up our podcast, what is the final takeaway, STESHA?
We have seen that while modern instruments give us a specific chemical identity for a conviction, practical wet chemistry like acid-based titration is far from that.
Exactly, it is the essential, cost-effective, first respondent that give environmental officer that the immediate data they need. Thank you for all experts rotating in, and thank you for watching the Neutral Zone. See you next time. So,